industrial accidents, personal injuries, lost wages and productivity. Common results of hand tool misuse and abuse. They could, however, be avoided. Every job instruction program should train employees in the safe, correct use and maintenance of hand tools. Many accidents and injuries in the industrial environment could be prevented with a qualified safety program like the one that follows. Always use approved eye protection. Use the correct tool for the job. Use the tool correctly. Maintain the tool regularly. If these four major points of hand tool safety sound simple, they are. Hand tool safety is a very simple program of common sense tool use and proper tool maintenance. Maintenance and safety requirements in modern industrial plants need a wide variety of common hand tools to perform the work. To ensure having the correct tool for each job, your maintenance tool sets should have a wide selection of both inch and metric size sockets and drive handles. Wrenches, screwdrivers, hammers, pliers, and other tools. Quality hand sockets are distinguished by a rust-resistant chrome finish and thin wall design. The thin walls provide a clearance advantage over other types. Never use hand sockets on power or impact equipment. They will not withstand the repeated impact loads in power and impact uses. If misused in this manner, a hand socket could fail and cause an injury. Impact sockets have thicker walls for resisting repeated impact loads. These sockets provide the best combination of toughness and strength for impact applications. Power sockets look similar to impact sockets but have thinner walls and are designed for longer wear resistance. Interchanging power and impact sockets can lead to rapid socket failure and possible injuries. Also, don't confuse black finish hand tools with sockets designed for power or impact applications. A socket and drive handle combination is only as safe as the retention system used to secure the socket to the handle. The retention system used for a particular socket is usually determined by that socket's intended application. Friction ball is the most common retention system for hand tools. A spring-operated ball engages machined grooves in the socket square drive. A firm pull releases the socket from the handle. Friction ball retention is usually found on 1/8 inch through 1/2 inch drive hand sockets. Many 3/4 inch and 1 inch drive hand sockets use a convenient lock socket release button retention system. A spring-operated button in the male drive enters a hole in the socket square drive wall. The socket is released from the handle by pressing the button. Most power sockets use locking button retention to prevent accidental release. A spring-activated button enters a hole in the socket square drive wall. Depressing the button with a small rod or pin punch releases the socket. Large size impact and power units use pin and ring socket retention for greater safety. A steel or plastic pin is inserted through the socket wall and square drive. A rubber ring securely holds the pin and socket in place during use. A modification of this system has the pins and ring molded together into a one-piece socket retainer. Sockets need regular maintenance just like other tools. Inspect your sockets before use. Dirt and grease can prevent a socket from seating properly on the fastener. This places extra stress on the socket walls and could cause the socket to fail. Immediately replace any sockets that are cracked or show signs of wear. Always use approved eye protection when using power and impact sockets. Never put your hand around any flexible or other impact socket during use. A good selection of quality socket handles is the easiest and safest way to perform a multitude of wrenching tasks. Always use the largest drive size ratchet or handle available to prevent accidents and avoid tool failures. Always inspect your ratchets regularly before use. Any worn parts should be immediately replaced with the complete contents of a repair kit. Never replace parts individually. Regularly lubricate your ratchets with a light grade oil. Always use the tool properly. Using a cheater bar or pipe extension on any ratchet can overload the square drive and gearing of the ratchet. The excessive leverage can result in a broken tool or bodily injury. Although readily available, step-up and step-down adapters are potentially dangerous and are not recommended for general use. This type of substitution is usually the result of not having the correct tool for each job. Excessive leverage on smaller square drive units could result in tool failure. Adapters designated for hand tool use only should never be used for impact and power applications. Quality drive handles are designed in proportion to the load the square drive will handle. For higher leverage jobs, use a larger drive size ratchet head with heavy-duty handle extensions. The handle extensions are secured to the ratchet head with a locking button for safe and secure retention. Proper use of torque measuring instruments is always a critical element of tool and operator safety. A bolt not tightened to specification could easily vibrate loose. An over-tightened bolt could break under the stress. Never use a torque wrench for the initial loosening of a fastener. Although the handle and square drive may withstand the leverage, the sudden release of tension may damage the internal mechanism. Use a breaker bar and socket combination to loosen the fastener. For high torque applications, a torque multiplier provides the safest way to remove or tighten fasteners. Torque input from the ratchet is multiplied several times through the gearing. The solid handle of the multiplier is braced securely against an object strong enough to withstand the torque load. Newer model torque multipliers have the anti-backlash system built in. This setup maintains torque in the geared head wrench and allows the user to get a new bite from the ratchet. Torque instruments also need periodic maintenance. To ensure consistent accuracy and prevent damage to the wrench mechanism, only use a quality torque tester or qualified service center to test and calibrate torque wrenches. Some torque wrenches feature ratcheting mechanisms that require cleaning and lubrication. Any worn parts should be replaced. Open ends, combinations, box ends, and other specialty wrenches are all used in industrial maintenance. They too have their own guidelines for safe and correct tool use. Quality open-end wrenches use a continuous arc design to distribute stress around the entire radius of the wrench head. This makes for a safer and stronger tool. Quality wrenches also feature design variations like angled or offset heads for specialty applications. Select the correct wrench for the intended application. Open-end wrenches are designed for low clearance work. Use a box wrench instead of an open end where possible. The box design provides a more secure grip and greater strength because it completely encircles the fastener. Make sure the wrench head is properly seated on the fastener. Cocking the wrench at an angle concentrates the strain at one point, making the tool vulnerable to fracture or damage. Safe use of all wrenches requires that the user be alert and prepared for any possibility. Always pull on the wrench and adjust your stance to prevent a fall in case the wrench or fastener slips or breaks. When a job requires greater leverage, select a heavy-duty box wrench and tubular extension handle. This wrench style uses locking button retention to securely connect the wrench and handle. To free even larger fasteners, a sledgehammer wrench should be used. Position yourself so there is no chance of injury in case the hammer glances off the wrench at impact. A dead blow sledgehammer is best for this application because of the reduced rebound effect. When using an adjustable wrench on a job, make sure you use it correctly. Adjust the wrench tightly to fit the nut, and pull so the stress is applied to the fixed jaw of the wrench. When using an adjustable wrench together with another wrench, hold with the adjustable wrench and turn with the other wrench. Pipe wrenches require the same safe use as other adjustable type wrenches. Pipe wrenches should always be securely tightened against the pipe or fitting before applying any force. Never use pipe wrenches to turn nuts and bolts. Damage to the fastener or wrench teeth could result. Using cheater bars or hammers to apply more torque could also lead to tool failure and injury. The screwdriver is probably the most abused tool in any tool inventory. Screwdrivers should never be used as punches, chisels, pry bars, or scrapers. Using a screwdriver that doesn't fit the screw slot is a common form of screwdriver abuse. Mismatched tip and screw sizes could result in a damaged tool or injury if the screwdriver should slip. The correct size tip seats firmly in the screw slot and won't project beyond the screw head. Pay close attention to the tip configurations of your screwdrivers. Many tool users often confuse Posi-Drive and Phillips-style screwdrivers. Quality screwdrivers help identify various styles of tips. Here, the red handle helps identify a Posi-Drive style tip. Special application screwdrivers also help match the correct tool to the job. Clearance problems may prevent a standard length screwdriver from seating properly in the screw slot. This is a potentially dangerous situation. A stubby screwdriver is the correct and safe tool for this use. Ratcheting screwdrivers are popular special application tools. They provide a variety of interchangeable tips to do the job safely and quickly. Screw starters are useful for starting screws in restricted access areas. They can prevent screws from getting lost or dropping into moving machinery. Many quality screwdrivers have hex bolsters to allow wrench-assisted turning to safely loosen stubborn fasteners. The hex bolster models also prevent the blade from being forced into the handle. Always apply enough pressure to maintain positive contact between the tip and screw slot to prevent any accidental slippage. Never pound on a screwdriver handle with a hammer. The tool could bend or break and cause an injury. Screwdriver maintenance is fairly simple. To ensure a positive non-slip grip, always keep the handle clean of oils and solvents. Inspect the tips of your screwdrivers before use. Rounded edges or blunt points will slip out of the slot and damage the fastener or cause an injury. Never redress screwdriver blades with a bench grinder. Grinding generates excessive heat, which can change the temper of the blade and lead to possible tool failure. Flat screwdriver blades should be redressed with a hand file. Hammers are made in various types and sizes with degrees of hardness and different configurations for specific uses. Having the right hammer available for the right job will promote safe and correct tool use. A shot-filled soft face hammer is one of the safest hammers to be found in a maintenance tool inventory. The dead blow design helps reduce the rebound effect. Ball-peen hammers are intended for striking punches and chisels and for shaping or straightening unhardened metal. Dead blow ball-peen hammers are even better for this use because the shot-filled head directs the impact downward. When the work surface must be protected from damage, use a bronze or plastic tip hammer. Many have replaceable tips which allow greater job flexibility from a single tool. Non-sparking hammers should be used in situations where a stray spark may pose a fire hazard. Always strike the hammer parallel to the striking surface. This will help prevent dangerous glancing blows and possible injuries to the user. When striking another tool like a punch or chisel, the striking face of the hammer should have a larger diameter than the struck face of the tool. Never strike one hammer against another. They are not intended or designed for such abuse. Inspect your hammers before use. Make sure the handle is clean and dry to avoid slippage. The handle should be securely attached to the head. Immediately discard any hammer that shows signs of excessive wear, chipping, or cracking. By design and intended use, punches and chisels are always potentially dangerous hand tools. Always wear approved eye protection when working with striking tools. Cold chisels are used for chipping, shearing, or cutting metal. There are 4 basic styles of cold chisels: round, cape, diamond, and flat. Each style is designed and manufactured for a specific use. Always match the chisel blade with the size of cut to avoid overstressing chisel blade points. A chisel holder provides a secure grip and removes your hands from the direction of hammer blows. This reduces the chance that an off-center blow could cause an injury. Small pieces requiring chisel work should be securely clamped in a vise. Chip toward the stationary jaw of the vise and away from yourself. There are 4 basic types of punches: center, pin, starter, and aligning. Each is designed for a specific purpose. Always select the largest size possible. Since center punches are used for marking metal, don't use them to drive pins. The hardened sharp point of a center punch could cause the pin to expand and bind in the hole. Use a starter punch instead. The tapered shaft will withstand the needed impact to knock out rivets or loosen frozen pins. Use a pin punch to complete the job. It will follow the pin through the hole. Starter and pin punches are usually stamped with tip diameter sizes. They should always be used in pairs to ensure that the correct tool is being used for the job. Use bronze punches where sparks could be dangerous or damage to the struck surface is possible. Bronze punches will require frequent redressing because of the softer metal. Punch and chisel maintenance is critical for safe use of these tools. Punches and chisels should frequently be inspected for signs of wear. Any chisel with cracked or chipped cutting edges should immediately be discarded. Mushrooming of the crown is a natural course of wear. The crowns are heat-treated differently than the working edge to absorb the shock of impact. The mushrooming reduces the danger of flying chips of metal. Tool crowns and chisel blades can be reconditioned with a hand file and chisel gauge. Do not use a bench grinder for reconditioning work. The heat generated will destroy the temper of the tool and could lead to dangerous tool failure. Always use approved eye protection when using files to recondition tools. For a safe, secure grip, any file you use should have a handle. File away from yourself to properly direct the displaced metal. Pliers come in many styles and designs to perform stripping, cutting, and bending jobs. Because of the many choices, it's important to use the right tool for the job and to use it correctly. Pliers were not intended to do the work of a socket or wrench, so don't use them to turn nuts or bolts. Tool or fastener damage could follow from such abuse. Electronic work involving smaller wire gauges and limited access areas usually require needle nose pliers for the job. Don't bend stiff wire with the tips. The tips could break or the jaw alignment can be damaged. Always use approved eye protection when using cutters. Do not use pliers for cutting hardened wire unless they're designed for that purpose. Never bend the wire back and forth because you will dull the cutting blades. Always cut at right angles and hold the short end of the wire to control loose ends, or use cutters with wire retainers to capture the wire stubs. In higher leverage applications, never increase plier leverage with pipe extensions or cheater handles. A high leverage cutter will handle the job safely. Many plier types feature plastic grips on the handles. These grips are designed for comfort only and will not insulate the user from live electrical circuits. The locking or vice grip style functions as a pliers, portable vise, or clamp. However, they are not intended to replace wrenches. Locking pliers are also widely used in welding applications. Remember to keep the torch flame well away from the pliers. Excessive heat can change the temper of the metal and lead to possible tool failure. Using the correct tool for the job is a main ingredient of tool safety. Sometimes the right tool isn't available because it doesn't exist. Don't try to modify existing tools to your needs. Don't try to make your own tools. Most modified tools don't have the proper temper or heat treatment to handle the job safely. Leave your special tool needs to your industrial tool expert. Usually his company will have the resources and expertise to manufacture the correct and safe tool for your special application. Your industrial tool expert can also help you improve an often neglected area of hand tool safety: tool storage and tool management. A quality tool storage program allows for periodic inspections of all tool inventories. Your tool expert can help you design a tool control program that can be tailored to meet your exact needs. There are many aids which promote tool management. They allow you to select the right tool quickly and maintain inventory. When it comes to storing your tools, use large, roomy storage units designed for industrial use. Always check for tools and loose parts that could fall off during movement. Each drawer should be closed before opening another one. Too many open drawers can create an unsafe condition and cause the storage unit to tip over. Close and lock all drawers before moving the storage cabinet to a new work area. Always push a roll cabinet in front of you so you can see where you're going. Tool safety is everyone's job. Since most accidents with hand tools occur because of tool abuse or poor tool maintenance, a qualified hand tool safety program can reduce injuries to workers. Every facet of hand tool safety discussed in this program evolves from the 4 major points of hand tool safety. Practice them and make them the foundation of your safety program. Always use approved eye protection. Use the correct tool for each job. Use the tool correctly. Maintain the tool regularly. That's hand tool safety, a program of simple, common sense do's and don'ts that are very important to your safety. And your safety is important to us.